Okay. Hello students. Yesterday was our first lecture regarding matrices, and I gave you the introduction of matrix and types of matrices. Yesterday we had stopped, I think, on this scalar matrix, and now today we will move forward from where we had left off. So I think the next topic which we have to start is from identity matrix. Okay. Okay. What is an identity matrix? It is a square matrix. It is a square matrix in which all diagonal elements are 1. In which all diagonal elements are 1 and non-diagonal elements are 0, and non-diagonal elements are 0. So what is identity matrix? Identity matrix is a square matrix in which all diagonal elements are 1 and non-diagonal elements are 0. Suppose we want to write the theoretical definition. I will write, let A is equal to Aij n cross n be a given square matrix, because for a matrix to be an identity matrix it has to be a square matrix. So let A is equal to Aij n cross n be a given square matrix. If Aij is equal to 1 for I is equal to j is equal to 0 for I is not equal to 0, then by definition A will be an identity matrix. Why Aij is equal to 1? Because at the diagonal places the value of I is equal to j, which we had learned yesterday. And sorry, I mistake over here, I is not equal to j. And when I is not equal to j means for non-diagonal elements value of Aij will be 0. Then A is an identity matrix. Okay. Now, still I think few students might have some confusion. So what I will do is that I will write the definition again. Discussing with identity matrix. Identity matrix. What are the points for it? It is a square matrix first. This is the square matrix, and all diagonal elements are 1, and the third point is all the non-diagonal elements are equal to 0. All non-diagonal elements are 0. This is the subjective definition of identity matrix. Now let me write it in mathematical form. Again, let A is equal to Aij n cross n be a given square matrix. Now for it to be an identity matrix, diagonal elements have to be 1, non-diagonal elements have to be 0. So if, okay, I'll write over there so that you can understand in a better way. At diagonal places, for diagonal elements, value of I is equal to j, and at non-diagonal elements, the value of I is not equal to j. And if you can recollect, Aij is element in ith row and jth column. So for it to be a identity matrix, if Aij is 1 for I is equal to j, means at diagonal elements I is equal to j, Aij will be 1, and for non-diagonal elements I is not equal to j, then Aij will be equal to 0. Then A is an identity matrix. I hope now it must be clear. Identity matrix, okay. Identity matrix of order n cross n is denoted by in. So identity matrix of order n cross n is denoted by in. And then I will give you example of identity matrix of order 1, order 2, order 3. And in our syllabus, we have identity matrices till order 3 only. So, IN is equal to identity matrix of order n cross n. So, example. I3 will be actually equal to I 3 cross 3. So I3 can be written as main diagonal has to be 1 and non-diagonal elements have to be 0. So I just wrote 1 on the main diagonal at the diagonal and 0 at the non-diagonal places. So this is I3, identity matrix of order 3. Then I will write I2. I2 is identity matrix of order 2, or you can say 2 cross 2, and I1 will be identity matrix of order 1 cross 1, that is 1. Therefore, I2 is I2 cross 2, but we prefer to write I2, and I2 will be at the diagonal elements are 1 and non-diagonal elements are 0. Similarly, I1 is I1 cross 1 and I1 will be only 1. Because what? Because this element is in first row, first column, so I is equal to j. So it has to be 1 only. So this is example of identity matrix of order 2. That is an example of identity matrix of order 3, and this is example of identity matrix of order 1. I hope this is clear and understood. I think I gave the definition twice, and I gave the examples of I1, I2, I3. So I hope now this is a simple topic and it is clear to everyone. And suppose you have any doubts, trust me, when I will solve one or two questions, it will be clear. So don't worry about it. It is not very tough. Just go through whatever I have written, and yes, you have take notes of it, and I think that is enough for you to understand, and you will easily get it. Okay. Now let's move forward to the next topic. The next topic is, after identity matrix, is a zero matrix. Okay, now that is really very easy. Zero matrix. The name suggests it has all elements 0 and it can be of any order. So all elements of a zero matrix are 0. All elements of a zero matrix are 0. It is denoted by O. It is denoted by O. So any zero matrix of order m cross n can be written as zero matrix of order m cross n is O, which is equal to O m cross n, and we can write as a matrix. All elements are 0 and the order is m cross n. However, clear, zero matrix of order m cross n is O. O is O, m cross n is equal to a matrix having all elements 0 of the order m cross n. I will write it again. Matrix O has the order O m cross n, and it is equal to having all elements 0 and it is of the order m cross n. So this is a zero matrix, and you can give examples like very easily. Many examples are there, like this is 1 cross 1. Then you can write 0, 0, 0, 0, 0, 0. It has order 1, 2 rows, 3 columns, so 2 cross 3. But I hope this is sufficient to understand what is a zero matrix, and I think very easily you have understood. I have no problem regarding zero matrix. So zero matrix is a matrix having all elements 0. It should not be taking much tension about it. It's very simple. The name suggests zero matrix. All elements are 0 and it can be of any order. Okay. Now, moving on to the next topic before the first exercise is equality of matrices. Equality of matrices. Equality of matrices. Two matrices are said to be equal. Two matrices A and B are said to be equal if, first of all, they should be of same order and corresponding elements of A and B must be equal. I hope that is very clear. Two matrices A and B are said to be equal if, first point, A and B are of same order. Second, corresponding elements of A and B must be equal, are equal. Equal. So what is the definition of equality of matrices? Two matrices A and B are said to be equal if A and B are of same order and corresponding elements of A and B are equal. Okay, let me give you the mathematical unit, means how they write. Two matrices are suppose A and B. So I will write let A is equal to Aij m cross n, B is equal to Bij of the order m cross n. Why I am taking the two matrices of the same order? Because for matrices to be equal, they must be of the same order. So what I have taken is that here I have taken both A and B of same order. And now what I will write? First of all, since they are equal, A and B are equal matrices, therefore A is equal to B. A and B are equal matrices. It is given. Suppose if I assume, so A is equal to B, and then what I will write? And then I will write Aij is equal to Bij. That is the matrix. Aij of the order m cross n will be equal to matrix Bij of the order m cross n. Both are the same order, so we need not worry about it. Therefore, the corresponding elements are equal. Every element of A is Aij, every element of B is Bij. Therefore, Aij will be equal to Bij for all I comma j. I hope I am clear. Means they are equal matrices, so their order has to be same and all corresponding elements are equal. So this is the definition of equal matrices. Nothing very tough and not much to get confused about it. I hope I am clear. I think this is the theory which is required. This is the theory which is required for the first exercise, which I will start, and maybe if possible I might finish off in this lecture. And I will try to finish it in a way that you understand each and every question. I will leave few questions for you as a homework, and you solve those questions. And if you have any doubt, you can easily ask me, or if I get a list of many doubts in one lecture, I will then solve all the difficulties, and later on I will inform you that in this lecture I will be only discussing the difficulties of a particular exercise or a particular examples and all. So you need not worry about it. Personally, I believe you will not have any doubts. You can solve it on your own. Okay, now, so let us start with the first exercise, and I might solve few examples before it. Let me see, and then I will start with the exercise. First, let me see. I will try to solve those examples which have some connection with the exercise, so that you can understand in a much better way. Okay. First of all, let me go with example 2. Example 2. It has, a matrix has 8 elements. The matrix has 8 elements. What are its possible orders? Okay. See, this is very simple. Okay. We know solution. We know if order of a matrix, yesterday we had, if order of a matrix is n cross n, then number of elements in the matrix will be mn. So if order of the matrix is n cross n, the number of elements in the matrix will be number of rows into number of columns, that is mn. That we know it. So now number of elements is what is given? 8. So what I will do is that I will find those factors of 8 whose product will give me 8. So what I will write is 8 is 1 into 8. I can also write as 2 into 4. That I can write as 4 into 2. And that I can write as 8 into 1. These are possible ways. These are 4 possible ways. These are 4 possible ways of expressing 8 as product of 2 natural numbers. So this will be the 4 orders of the matrix which is required. So possible orders are 1 cross 8, 2 cross 4, 4 cross 2, 8 cross 1. I hope this is simple, not at all tough. Personally, I believe this is very easy. Or you can say the same question they can ask, how many such matrices are possible? So you will have to write 4 possible matrices, means first matrix, second matrix, third matrix, 4 matrix. So 4 possible orders. I'll write refer to mine over here. 4 possible orders are 1 cross 8, okay, 2 cross 4, 4 cross 2 and 8 cross 1. So this was the example 2. Personally, I feel not very tough. In the textbook, in the exercise, there are I think 2 questions which I will explain when I will start with the exercise. So this was the Example number 2 of matrices. Now let me see which is another one such example which I can solve immediately. Okay. One is example number 4. Let me solve example number 4. What is given? It is given that two matrices are given equal. X plus 3 minus 6, B minus 3, Z plus 4, A minus 1, minus 21, 2y minus 7, 0, 0, equal to 0 minus 6, 0 minus 6, 2b plus 4, 6 minus 3, 6 minus 3, minus 21, 3y minus 2, 2c plus 2, and 0. This is what is given. And they have asked in example 4, these two matrices are given as equal. And we have to find the values of the unknowns, which is x, y, z, a, b. These are the 5 things which you need to find. And c also. X, y, z, and a, b, c. We have to find x, y, z, a, b, c. This is 1, 2, 3, 1, 1, 1. This is a 3 cross 3 matrix. And this is also 3 rows, 3 columns, so 3 cross 3 matrix. So two matrices are equal. So can I say respective elements will be equal? So x plus 3 will be equal to 0 and z plus 4 will be equal to 6 and 2y minus 7 will be equal to 3y minus 2 also. Okay, also minus 6 is equal to minus 6, a minus 1 will be equal to minus 3 and 0 is equal to 2c plus 2 and b minus 3 is 2b plus 4, b minus 3 is equal to 2b plus 4 and obviously minus 21 is equal to minus 27, minus 21, 0 is equal to 0. So this is as per equality of matrices, because equality of matrices. And now we just have to solve these equations and we will directly get the values. It's very easy. So now x plus 3 is 0. So what I get? X plus 3 is 0. So I will directly get x plus 3 is 0. So directly x I will get as minus 3. Z plus 4 is 6. So I think z will be 6 minus 4 2. Here I need to solve for y. A I will get directly. C I will need to solve somewhat. And B I need to solve somewhat. So what I will do is that I will solve very fast because we have noted down all this. So first of all, x plus 3 equal to 0 implies x will be minus 3. Therefore, z plus 4 is 6 implies z will be equal to 2. So x and z will found out. Now let us go with y. 2y minus 7 is equal to 3y minus 2. That gives me, implies that gives me 2y, 3y minus 5. So y is equal to minus 5. A minus 3, a minus 1 is 3. A minus 1 is right over there. Suppose someone is, I hope, if I have done this directly, I hope no problem. You want to write something like this, I will write 2y minus 3y is minus 2 plus 7 implies minus y is 5 implies y is minus 5. So that three unknowns we have found, x, z and y. Now the three unknowns which are remaining, one equation which was for me was a minus 1. A minus 1 was minus 3, a minus 1 is equal to minus 3. That implies directly a is equal to minus 3 plus 1 minus 2. Similarly, 0 is equal to 2c plus 2 implies 2c is equal to minus 2 implies c is equal to minus 1. The last equation was regarding b, and b minus 3 is equal to 2b plus 4 So that comes out to be 2b minus b is b is equal to 2b minus b, or I will write b minus 2b is minus b, 4 plus 3 7, so b is minus 7. So finally we end up writing all the values of the variables which were asked. X is minus 3, x is minus 3, then y is minus 5, z is 2, a is minus 2, b is minus 7, c is minus 1. Relatively very easy, not tough. That was example number 4. Okay, that was example number 4. Then I will move on to the exercise, which is exercise 3.1. Personally, I think that is relatively very easy exercise, and you all can manage to do it on your own. Not tough very questions, one or two only are relatively tough questions, and I will solve few questions, and I might leave few questions for you as homework. You solve it, and you can ask me if you have any doubts. Okay, now and you need to be very sincere while doing these calculations, and you need to make notes after watching my lectures, and do it again and again and again, because you don't have to go to school, you don't have to go to tuitions, you are at home. So better use the time in the most effective way, and we don't know when the schools are going to start. So it's better that the chapters which are being taught to you by me through this way, you revise it again and again and again and again. So you are very perfect when these chapters are over. So you need not revise it more when suppose when the school starts. So you're perfect with all these chapters. So practice it more and more and more. Okay, exercise 3.1. Let me start with exercise 3.1. Question number 1. Okay. Well, they have given the matrix A is equal to 235 root 3. I'm writing column wise. 5 minus 2, 1. 19, 5 by 2, minus 5, minus 7, 12, and 17. They have asked you things. First, they have asked order of the matrix. Now see, how many rows are there? 1, 2, 3. 3 rows, horizontal is rows, and vertical is columns. So 1, 2, 3, 4. So 4 columns. So it is a 3 cross 4 matrix. So what is order? Order is number of rows cross number of columns. 1, 2, 3. 3 rows, 4 columns. So that is the first part which they have asked. First is the order of matrix. Second thing which they have asked is number of elements. What is number of elements? Number of elements is number of rows into number of columns. That we did yesterday. So, number of elements is equal to number of rows is 3, number of columns is 4, 3 into 4, 12. So that is also very easy. And in the third part, they have asked few elements. Write the elements, they have given few. So I will write A13. The element in the first row and the third column. First row, third column. So first row, so I will search first row and third column. So first row and the third column. So A13 has to be 19. Then they have asked A21. A21 is in second row, first column. It is in second row, first column. So second row, first column. Second row, first column. So 30. So A21 is 35. Then they have asked A33. A33 is in third row, third column. So 1, 2, 3. Third row and third column. So first, second, third. The third row, third column is minus 5. So it has to be minus 5. So A33 will be minus 5. A to 4. Second row, and fourth column. 1, 2, 3, 4. Fourth column. Second row, fourth column is 12. So it will be 12. And the last one they have asked is A to 3. So second row, third column. So second row, third column. So it has to be 5 by 2. Let's prefer. I just hope I have not done any mistake while writing these elements. You need to be very, very, very careful while writing all this. You need to observe. Right. I hope I'm clear. This is the way the first question has been asked. It's a simple question. I think everyone can do it without my help, but I just did it because the first question, and you have to say that okay, the exercise is easy. You solve one or two questions, they're easy, and then the confidence builds. Okay, now the next question. Actually the next two questions are exactly the same as the example 2 which I did. So I will solve one of that question number 2. Okay. I will leave question number 3 as homework. Okay. So question number 2 says a matrix has 24 elements. What are the possible orders it can have? And the same thing they have asked, what if it has 13 elements? So not right. The first case is matrix has 24 elements. Matrix has 24 elements. That is given. So without wasting much time, 24. In example 2, what I did, that a matrix, number of elements in a matrix is equal to number of rows into number of columns. So 24, I will write all the possible factors of 24, or I will express 24 as product of two natural numbers. So 24 can be thought of as 1 into 24. It can be thought of as 2. Okay. You can also write as 24 into 1 over here only. 2 into 12, so 12 into 2, so that you don't miss. 3 into 8, which is equal to 8 into 3, which is equal to 4 into 6, which is equal to 6 into 4. So 24 can be written as 1 into 24, 24 into 1. In this way, 8 different ways. And these all different ways are the possible orders of this matrix. So, 8 possible orders are 1 into 24, 2 into 12, 2 cross 12 you can say, 3 cross 8, 4 cross 6, then it's very easy, 6 cross 4, 8 cross 3, 12 cross 2 and 24 cross 1. So how many such matrices are possible? 8 such matrices are possible. That's the first part. Matrix is 24 are possible, or how many? Write all possible 8 orders. So everything given. And the same question they have asked, what if it has 13 elements? Second case, matrix has 13 elements. So this is relatively easy. So 13 I can write as 1 into 13 or 13 into 1, because 13 is a prime number. So we can express it as product in only these two possible ways. So two possible orders are 1 cross 13 and 13 cross 1. I hope I'm clear. Easy, not tough. This is question number 2 of the exercise. Third is a same question. So personally I believe you can do it as a homework, not a problem. Okay, personally I feel that's easy because I have already done example number 2 and I have question number 2. So you can do question number 3 as homework because it's the same question, same time. You will get an idea and you will get the answer. Okay, now coming to question number 4. Now so question number 4 has 3 subtypes. Oh, let me do, maybe I might do 1 or 2. Okay, they have asked to construct a 2 cross 2 matrix. Okay. A equal to Aij is a 2 cross 2 matrix, is a 2 cross 2 matrix given, and we have to find all its elements. So A will be 2 cross 2 means it has how many elements? 2 cross 2 means it has 4 elements. So So the four elements will be, the first element will be A11, first row, first column. Second will be first row, second column. So A12. Here the third element, if I point my finger over here, it will be second row, first column. So it is A21 and here it is to be A2. So since the order of the matrix is 2 cross 2, number of elements in the matrix will be 4, and this is the way it is the matrix which you have to. This matrix can be written in subjective way like this. Now they are given the formula for Aij, and based on that formula we have to construct the matrix, given matrix. In the first case, they have given the formula of Aij given in the first one is Aij is equal to I plus j the whole square by 2. I plus j the whole square by 2. So for finding A11, I will write I is 1 and I is equal to 1 and j is equal to 1. So I will substitute I is equal to 1 and j is equal to in this formula. So A11 will be equal to 1 plus 1 the whole square by 2. 1 plus 1 is 2. 2 square 4. 4 by 2 is 2. So therefore A11 is 2. Okay, then A12 I will be equal to 1 and j will be equal to 2. So that will be I plus j the whole square. So 1 plus 2 the whole square by 2. 1 plus 2 is 3. 3 square 9. 9 by 2. So therefore A12 will be equal to 1 plus 2 is 3. 3 square 9. 9 by 2. So A12 is 9 by 2. Then the third was A21. A21. For A21 I is 2 and j is 1. So that will turn out to be, the formula is I plus j the whole square. So 2 plus 1 the whole square by 2. 2 plus 1, 3. 3 square 9. 9 by 2. So ultimately, therefore, A21 is 9 by 2. And the last one is A22. The last one is A22. So A22, I has to be 2 and j has to be 2. So that will be I plus j. So 2 plus 2, the whole square by 2. 2 plus 2 is 4. 4 square 16. 16 by 2 is 8. So we end up getting A22 as 8. So we have found out the 4 elements A11, A12, A21 and A2. So finally we have found out all the 4 elements of the required matrix. So what I will do is that I will write finally the matrix. A was A11, A12, A21, A2. Okay, I just rubbed off what was that. A1, 1. 1 plus 1 was 2, 1 plus 1 was 2, 2 square 4, 4 by 2, I think it's 2. If I'm not wrong, I can just check. Yeah, A11 was 2 only. So A11 is 2, A12 is 9 by 2, A21 is also 9 by 2, and this is 8. So this is the final answer. So the required matrix A is 2, 9 by 2, 9 by 2, 8. So answer correct. 2, 9 by 2, 9 by 2, 8. Yes, answer is correct. This is the first one given. The first part which they asked. You have to construct a 2 cross 2 matrix where Aij formula was I plus j the whole square. Okay. Now I will give another one, the second part in it, which was given as the second formula of Aij is given. Let me solve that. Maybe that will be clear in a much better way and you will understand in a much better way. This way. You understand? This is the first question which we have done. So few students might have some doubts. Keep the patience. Just wait. I will solve one more question and I think you will get it. And then it becomes very, very, very easy. Obviously, first step has to be tough and then it's easy. Second one is, in the second one, A equal to Aij. I'm giving the same question number 4. A is equal to Aij. It's a 2 cross 2 matrix, and here with Aij formula is given as I upon J. So obviously we know A has to be, since it is 2 cross 2, A will have 4 elements. The first element is A11, A12, A21, A22. It's 2 cross 2. And now I will find A11, A12, A21, A22 using the formula Aij is equal to I by J. So for A11, I is 1, J is 1. So it's 1 by 1 is 1. So I can say A11 is 1. Easy. For A12, I is 1, J is 2. So answer will be I by J. So it's 1 by 2. So therefore A12 is 1 by 2. For A21, I is 2, J is 1. Formula is I by J. So 2 by 1. So it's 2. And A22, where I is 2, J is 2, will be 2 by 2. 1. So finally, A11 is 1, A12 is 1 by 2, A21 is 2, and A22 is 1. So therefore, A will be A11, A12, A21, A22. That I can write as 1, 1 by 2, 2, and 1. That is the answer. Whether I am right or wrong. 1, row wise 1 by 2, 2, 1. Yes, the answer is right. This is the simple question. The third one is same as I plus 2j the whole square. So personally I feel that third one you can do as homework. That is not a big issue and you will definitely get it. But that does not mean that I am not solving another such question. That is question number 5, the same type, and there is one example given in the textbook. So what I will do is that I will solve one example and then I will solve one type from question number 5. Okay. So let me first solve that question number 5. One of the parts asked. Construct a 3 cross 4 matrix whose element is given by Aij is equal to 2i minus j. Okay. Let the required matrix let A is equal to Aij. And in question number 5, the matrix is a 3 cross 4 matrix. So let A is equal to Aij, 3 cross 4 matrix. Okay. Here, formula for Aij is given as 2i minus j. Okay, this is given. So, since it is 3 cross 4 matrix, A will have 12 elements. So, A will have 12 elements and it will have 3 rows and 4 columns. So, the first element has to be A11, then it has to be A12, A13. First row, third column, and A14. And then second row, so A21, A22, A23, A24, A31, A32, A33, A34. So this is the matrix which we have to find. And the formula for Aij is, any element is 2i minus j. What I will prefer is that I will prefer to find out the answer directly without mentioning what is I and j. In the previous two questions of, you can say 2 types of given asked in question number 4, I have written what is the value of I, what is the value of j. So for A11, I is equal to 1, j is equal to 1. For A12, I is 1, j is equal to 2. ऐसा मैंने लिखा था. इस बार मैं ऐसा कुछ लिखूंगा नहीं. I will not write it. Okay, so directly I prefer to find. So A11, I is 1, J is 1. So 2 into 1 minus 1. So it's 2 minus 1, which is 1. A12, I is 1. So 2 into 1 minus 2. So 2 minus 2, which is 0. A13 is 2 into 1 minus J is 3. So 2 minus 3, which is minus 1. A14, so 2 into 1 minus J is minus 4. So 2 minus 4, which is minus 2. A21, so A21 is I is 2. So 2 into 2 minus 1. 2 into 2 minus 1. 2 to the 4, 4 minus 1 is 3. Now I will skip few steps. You also have to do it in that way. I is 2, J is 2. 2 into 2 minus 2. 2 to the 4, 4 minus 2 is 2. Otherwise we will not be able to accommodate everything. Otherwise we will be taking 1 month, or maybe 2 months for finishing this determinants and matrices. And then we will require 2 years or 3 years to finish off the 12th syllabus, and I don't know what will be then done. So A23, the formula was 2I minus A. So 2 into 2 minus 3. 2 to the 4, 4 minus 3 is 1. Okay, so found, and then similarly A23 found, and then A24. So 2 into 2, 2I minus J. So 2 to the 4, 4 minus 4 is 0. A31, 2 into 3 minus 1, 2 3s are 6, 6 minus 1, A is 5. Then A31 found out, A32, 2 into 3 minus 2, 3 to the 6, 6 minus 2, 8. A33, 2 into 3 minus 3, 3 to the 6, 6 minus 3 is 3. And the last one is A34, the last element. We have to find total 12 elements in this matrix. So A34 is 2 into 3 minus 4. 3 to the 6, 6 minus 3 to the 6, 6 minus 4 is 2. So ultimately we have found out all 12 elements. A11, A12, A13, A14, A21, A22, A23. So total 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. I am with the 12 elements. Now I need to be very proper, because I have to write finally the answer. So let me write the final answer of the matrix. Therefore, A is equal to, okay, first element has to be A11. A11 was, I guess A11 was 1 if I'm not wrong. A11 was 1. Yes, A11 was 1. A12 is 0. A13 is minus 1. Let me write this somewhat down. Maybe you might not be able to see it. So therefore, A is equal to 2I minus A equal to 1. A12 is 0. A13 is minus 1. A14 is minus 2. So first row over. And the part is done. Then writing the 4 elements of second row. A21 is 3. A22 is 2. A23 is 1. A24 is 0. A31 is 5. A32 is 8, A33 is 3, and A34 is 2. So this is the required 1, 2, 3, and 1, 2, 3, 4, 3 cross 4 matrix is the answer. This is the required matrix. So this is a 1 mark question, okay? So you need to be very fast while solving these kind of questions. And your one calculation is wrong, your final answer will be wrong. Let me check whether my answer is right. The first column is 135, second column is 024, 024. 0, 2, 4. Let me see. See, here I done a mistake. 3 to the 6, 6 minus 2 has to be 4. So it has to be 4. This was a mistake. I did addition. So here it has to be 4. See. Mistake which happened, and if the final answer is wrong, we will get big 0. So you need to be very careful. Then minus 1, 3, minus 2, 0, 2. Yes, the answer is right. Here I made a mistake. Here, while calculating A32, 2 into 3, 6. 6 minus 2. Instead of writing 4, I wrote 8. What I did? I added. That's a mistake which happened in the flow. So you need to be very careful, because this chapter involves only calculations. If your calculations go wrong, only one element is wrong. The final answers. Okay. Sorry for the mistake which happened. Now, there is one more type in that question number 5 to construct 3 cross 4 matrix. What I will prefer is that I will prefer to solve one example 3, which is the same type but it has relatively less elements. So let me solve that, and you can solve the first part of question number 5 as homework because it has 12 elements to be found out. And I think since you are in mediation and you are relatively free, it's better you solve that question which has few calculations. So, okay, question number 5, example number 3 I am solving. Example number 3. Example number 3 says, construct a 3 cross 2 matrix whose elements are given by the formula Aij is half mod of I minus 3j. So, A is Aij of the order 3 cross 2 matrix. A is given matrix, A is required matrix. Okay. And here Aij is given as half into mod of I minus 3j. Okay. Now since A is Aij 3 cross 2, since 3 cross 2 is the order, it will have 3 rows and 2 columns. So 3 rows and 2 columns means 6 elements. So A will be, we'll write A 1 1, A 1 2, 3 rows and 2 columns. A 2 1, A 2 2, A 3 1, A 3 2. Let me check. So 3 rows and 2 columns. And now the formula which is given as Aij is half into mod of I minus 3j. So first of all, let me calculate A11. So what is the formula? Half into mod of, what is the value of I over here? I is 1 and j is 1. So it will be 1 minus 3 into 1. So it will be half into mod of 1 minus 3, which is, okay, so A11 has to be half into mod of minus 2, which is half into 2, which is 1. So A11 will be 1. Well, that's the same answer in the textbook. Okay, perfect. Then let me go with A12. A12, I is 1, J is 2. So half into mod of, the formula is given as Aij is half into mod of I minus 3j. So half into mod of I is 1 minus 3 into 2. Okay, 3 to the 6, 1 minus 6, so it has to be minus 5. So A12 has to be half into mod of minus 5. So it will be 5 by 2. So A12 will be 5 by 2. Okay. Now, in the next 4 elements, what I will do is that I will skip certain steps. So, the next will be, the next element is A21. A21. So, what I prefer is that A21 is half into mod of, in the place of I, we need to write 2 minus 3j. So, 3 ones are 3 into 1. So, it will be 3 ones are 3. So, 2 minus 3. So, half into mod of minus 1. So, it will turn out to be A21 will turn out to be half into 1. So, half. So, remember the formula. So, A21 will be half. Let me see, the answer is right. Yes, A21 is also half. The next is A22. The next is A22. Half into, what is the formula? Mod of I minus 3. So I is 2 minus 3 into j. J is 2. So it will turn out to be half into 3 to the 6. So 2 minus 6. So my mod of minus 4. So half into 4, which is 2. So A 2 2 turns out to be 2. Similarly, the next one which is remaining is A31. A31, the formula was half into mod of I minus 3j. So half into mod of, at the place of I will get 3 minus 3j. So 3 into 1. So 3 ones are 3. 3 minus 3 0. So half into 0. So that turns out to be 0. So A31 is 0. Let me see the answer. Yes, A31 is 0 in the book. So A31 is also 0. So all calculations are correct as per the example. And the last one is A32. Similarly, A32, the formula is half into mod of A minus 3j. So half into mod of, I minus 3j. I is 3 minus 3 into 2. So, what will be the final answer? A32 is half into mod of 3 to the 6. So 3 minus 6. Half into mod of minus 3. So A32 will be 3 by 2. Well, that is also correct. So all of the values are correct. So I will directly write the final answer, which is A is the required matrix. A is A1 was I think 1. A12, okay, that from that thing, half, and then 0, 5 by 2, and then 2, and then 3 by 2. So this is our 1, 2, 3, 3 cross 2 matrix. This is the final answer. So this is the question number 5, which we did. Okay, so it's better we end over here. And what you do is that you try to solve the remaining 5 questions which are given in the exercise and the examples. I will cover the remaining portion of the exercise. I will cover the remaining portion of the exercise in my next lecture, and I hope this is last question. I have to do it fast, so and I hope it was clear to you. Okay, so thank you and study properly. That's it for now.